G'day, welcome to another video. Today I'll be showing off the new state machine using the animation tree added in Godot 3.1. I'm using the Alpha 2 build. Download link in the description for the download page. Okay, so let's get started. Drag in the icon. Just gonna delete these two previous attempts of the video. Okay, so here we have the icon. Add a animation player. Create a new animation. Gonna call this one bounce. Okay, so click on the icon. Add a key using Bezier curves. Okay, starting at 0 seconds. I want to make simple bouncing type animation. If I play it, I want to get it a bit bigger. There we go, got my bounce animation. Just resets this anyway, so that'll be okay for now. Now I'm gonna make a new animation. I'm gonna call it wobble. Now I'm also gonna get another key using the X position. Insert a key here. Apparently the previous key was really high. Okay, insert a few keys. Play it. That looks fine enough for now. Create a new animation, called it idle, and it's just gonna do nothing. Okay, so now the animation player has bounce, idle, and wobble. Okay, add a child, and it's gonna be animation tree. So this tree, let's assign the animation player. Make sure you assign it. Turn it on active. After you put in the state machine, that is what we're using. Put it on active. Remember to put it on active. Make sure you do. Okay, so add an animation. I am right clicking here, so right click, add animation. What can you do? So bounce, idle, wobble from this animation player. That's why we assigned it right here. Make sure you assign it, animation player. I already did that. Okay, so at end is the preferred one. Makes it so it plays all the animation all the way through. Okay, now we connected them. Okay, so play the wobble. Plays once. Animation player. Let's edit bounce and wobble a bit. Make it so bounce and wobble loop infinitely. Okay, so now when it gets to the end, it just replays. Play idle, finishes that one. Plays idle, idle's not anything, so that's not anything special. Now play bounce, and you see it does the bounce animation. Okay, and this is the special thing with the state machine. It travels through the nodes to the next animation. So it goes first one, then second one, and then last one. And here we go. We can go back and forth. We can go to idle, and then back to wobble. And yeah, okay, so what we want to do now with the animation tree, add a new script. Now with this, I'm gonna delete the comments for a second. Now I'm gonna create a new variable. This is gonna be called playback, and it's gonna be of type animation node state machine playback. Okay, so playback is going to be equal to get parameters slash playback. Got it. And then playback start. What's it going to start at? It's going to be the starting node. So what's that going to be? It's going to be bounce. For this demonstration, and make sure active will be set to true. This should automatically be there, but I'm just doing that just in case. Okay, so using the default inputs, so is action just pressed, using the UI down, what I'm gonna do is go playback.travel. What's it going to travel to? Well, it's going to travel to this wobble right here. I'm going to minimize that. Wobble. And I'm also going to duplicate this, Control C and Control V. Make this UI up. And make this go back to bounce. So this should make it so that when I press down, it does the wobble animation. When I press up, it should do the bounce animation. It should go through the tree to it. So now it should print playback dot get current node, and then there we go. This should be our basic logic. So save the scene, and here we go. Put that up a bit. Now you can see what animation is being played. Okay, so if I press up, it goes up to the bounce animation. If I press down, it goes to idle, and then it goes to wobble. If you look down in the print output menu, you can see it going through them, and if you look up, you can see them doing the animations. And it does wait until it's finished. This is a very important thing. Makes it easier for you to do things. In a game, you could be like, if the playback get current node, just for example, if that was equal to attack animation, then you could do something like if touching enemy, then do damage, etc. And that's the type of thing you can do with it. very useful thing. With the animation player, you can edit any property, so you can make it so the collision box expands, you can make it so it shows, you can do whatever. And just for some more advanced networks, so here's one going from bounce to wobble, and now I'm going to delete that right here. Okay, so now I'm going to press bounce, it's going to travel through idle, from wobble to idle to bounce, and then it's going to go straight to wobble because of this extra movement right here. But if I go back to bounce, I can't go back and forth, and if I want to go to idle, I have to go all the way through. It picks the smallest route, the one that goes through the least amount of nodes. So this can be useful if you're doing stages of a boss, so it's like, as I did before, if the current node is equal to stage 3 idle, then it will do whatever it should do then. This is a very useful thing, and hopefully this video was helpful. If it was,
good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another Godot tutorial video. In this video, I'm going to be showing you how to set up a simple state machine in Godot, and we'll use the state machine to create an effect of an NPC moving around in, say, for example, like the Pokemon games, where an NPC will move around in the world, pause in different places, choose different directions, and we'll use a state machine to do this. So a couple things to note: this isn't a tutorial for beginners. You should have a basic understanding of programming in order to do this tutorial. And another thing is that the tutorial the system that I'm going to be using for the state machines is a simple system. It's a very simple state machine system. So if you have a more complicated game, you may need to use a different type of state machine than this one. But this works great for very simple AI or a simple character that doesn't need to have a complex state machine. So let's get started. We'll create a new project here in Godot Engine. Just going to come into Godot 3.1, simple states, create. One other thing, I'm also doing a Kickstarter for a Godot course, and so I'll have a link for that in the description. It's the 1-bit Godot course by Heartbeast. Learn Godot 1 bit at a time. So you can check out that link and see if it's something that would be interesting to you. Okay, we'll switch to 2D scene. We'll create a new node over here. We'll call this world. We'll save our scene here, run the game. It'll want us to choose a scene to be the first scene that runs. We'll choose world, and here we go. Our game is now running. Let's create our NPC now. We're going to create an entirely new scene that will be used for this NPC. Create a new 2D scene, and we'll call it NPC. It's NPC. And we'll add a new node as a child of this, and it will be a sprite. There we go. And we can drag our icon.png onto this texture right here, this texture area up here, and we've got our NPC set up now. We're also going to need a timer, so let's get a timer node, and that will be attached to our NPC as well. Our timer will be a one-shot timer, and we'll have it auto-start. Actually, I don't think we have to make it one-shot. We can turn that off, but we do want it to auto-start. Okay, now we're going to come back. Well, let's save this scene. Just do Control-S, save, click on our world, and we can actually drag and just drop our NPC into our world. You can see that as long as you have the world node selected, you can drag and drop the NPC into the world. Okay, save again, run our game, and we should see our NPC inside the world. Perfect. Now we'll attach a script to this NPC, so we can click this little icon up here, and NPC, that's a good name for our script, and this is where we're going to write our code. So the first thing we want our NPC to do, well, the first thing we need to set up is to set up an enum for the state. So we're going to use an enum, and we're going to use the match keyword in order to match our current state with an enum. And an enum is just an enumerator, which means it's basically a collection of variables that count. So we'll have idle, new direction, and move. So those are our 3 states. Then let's create a speed variable. So we'll do const speed. We'll set this to 100, and we'll do a state variable. Set this equal to idle. We'll get a direction. And we'll set this equal to vector2.write. Okay, we can get rid of all this and just leave the process function here. Inside of here, we're going to match. So a match is kind of like a switch statement, but it has a few extra features that make it a little bit more flexible than using a switch statement. So we're going to match state like this, and oops, we'll just say idle, pass. We'll just pass for now. Then we'll match with new direction, also pass, and we'll match with move, also pass. So you can see it's very similar to a switch statement, but this value right here doesn't have to be constant. It can change, and that's one of the differences. That's my understanding. There may be others that I don't know about, but that's the main one that I know. But that doesn't matter for us anyways. So for new direction, well, for move, we're actually going to call a function called move, and we'll pass it to delta. And so let's write that function now. So we'll say function move delta position, so our current position, plus equals direction, whatever our direction is set to, times speed times delta. So multiply by our speed and multiply by delta to keep things smooth. So our character should actually move now to the right if we stop and run our game. Well, actually, I lied because we're starting in the idle state, so let's start in the move state instead. And run the game, we should move to the right now. You can see our character does move to the right. So that's good. Now we're going to need a function to make it easy to choose between different values. So we'll make a new function, we'll call this choose. and it will take an array of values to choose from. And then we'll just say array.shuffle, so we'll shuffle that array, and then we'll return, get rid of that there, we'll return array.front. So we shuffle the array and then we grab the very first item in the array. So that's an easy way to choose between different values. Now that we've done that, we can easily set up our new direction up here. So we'll say direction equals choose, do the parentheses, and then we're going to do array brackets inside of here because we need to pass in an array to it. Say vector2.right, vector2.up, vector2.left, and vector2.down. And then once we choose a direction, we also want to choose a new state. State equals choose. Make sure you do your square brackets for the array, idle, and move. Okay, so we'll choose a new direction, and then we choose between the idle and the move state whenever we choose a new direction. Okay, now we need to use that timer that we have. So click on the timer, come over here, we're going to use its timeout function here. Click on this, click on NPC up here, and we do want to create a new function like this. We'll connect. So on timer timeout, what we're going to do here is first of all, we need to get access to our timer so that we can set the wait time on it. So timer, if you do the $sign and then type the name of the node, hit the child of this so we can get access to it. Here we're going to set its wait time, and we'll use our choose function again, and we'll choose between just 3 different wait times. So I'm going to do 0.5, 1, and 1.5. These are in seconds. Then we'll set our state. State equals choose. And this time we want to choose between all 3 states. Idle, new direction, and move. So whenever the timer goes off, whenever the timer counts all the way down, this function is going to run. run, and we'll choose a new state and set a new wait time. So we should be able to save this, and I think this will work now. Let's test it and see. We're moving to the right. Oh, it decides to move to the right again, and we just moved to the right off the screen. So you'll also notice that every time we press play, it's going to do the exact same thing. So even though it's random, we need to make sure that we've randomized our seed every time. So we'll bring up the ready function for this. This function will be called right when the NPC is put into the world. And so right when it's ready, we can do randomize right here. And this will make sure that our NPC doesn't do the same thing every time we run the game.
Here's the situation. You have a bunch of animations on your game character, but it's hard to manage the transitions between them. You've been writing tons of if statements, and every time you change something, it all breaks. We'll solve this with Godot's animation state machine. So we're starting out with this sprite sheet, which you can get in the link below. And I've already made a character and created the animations in the animation player for all of these different animations. We have run, we have some attacks, and all of them are set up and ready to go. And in our script, I have some generic movement, kinematic body movement. So if we were to play this scene, the character can move around, and we are reversing directions so they face in the direction we want them to face. But we want to play the animations at the right time. So assuming you have all that, you're going to want to add an animation tree. And in this animation tree, we're going to go over here to the tree root. We're going to select a new animation node state machine. And then for the animation player property, we're going to click assign and choose our animation player node, so that we'll be able to pull all the animations from that node. And now in here, we can start adding our animations. If I right click, I can do animation. Here I see all the ones that I had. So I can choose my idle animation. And I'm going to go ahead and I'm going to add the rest of them. And notice the message down here. If we click active on, now this is active and it will do the animations when we click on them. So run idle, run, attack. And now that we have the animations in here, we can make connections between them. Let's say we want to connect our attack to our idle. This button here connects nodes. So if I click that, I can draw and connect a line between idle and attack. And let's add the other one over here. And so now I have a line between idle and attack. Attack 1 goes to attack 2, and then attack 3 goes back to idle. So what happens when I click attack 1? Well, it plays, right? And attack 2 plays. But if I'm on idle and I click attack 2, we just see attack 2. And that's because these transitions by default are immediate, the switch mode on the connections. If I were to change this one, the switch mode to at end, which I could also do with this one, now what happens is if we're in the idle state and we want to transition to attack 2, it's going to play attack 1 first, complete, then play attack 2. Let's see that again. 1, attack 2. But now we stop because attack 2 doesn't loop, so when it reaches the end of the animation, it goes no further. Well, this one we can set to auto advance. So that means at the end of attack 2, it's going to go back to idle. Watch out, click attack 2, and back to idle. So let's connect up all the other animations. So here are our connections all made up, and so now we can transition from whatever state to whatever state. So when we're in idle, we can go to run, call on this connection. Run goes right back to idle. If you attack, you're going to come right back to idle. If you're hurt, you're going to come right back to idle. Then we have a die animation, which is not going to have a return. And we get there at the end, and we can mark that using this button right here as the end animation. And we can also mark idle here as the start animation. That way it will automatically be playing this one when the game starts. And just to show you can double up these things in the little room here, we can also add another copy of the attack 1 and attack 2 to make a double attack, which we can do like that. So these two add in auto advance. Now we have a way for us to do a double attack, as well as the individual single ones. Now how do we control this in code when we move? Let's go over to our adventurer's script here, and we're going to add some code to call those state transitions for our animation tree. And we're going to start by getting a variable that will hold that reference to the animation state machine. And in our ready, we're going to get that reference. So state machine equals animation tree get, and there's a parameter that we have to get. Parameters playback is the parameter one. Now we have a reference to that, and that's going to give us this root node, this animation node state machine node, which has all of the functions for calling the individual animations and making those transitions. So for example, let's start with the simpler ones. Let's say we want to be able to play the hurt animation when the player gets hurt. So whatever item is damaging the player could call the player hurt function, which is going to tell the state machine to travel to the hurt animation. And what travel does is find the shortest path between current node and the one. As well as the individual single ones. Now how do we control this in code when we move? Let's go over to our adventurer's script here, and we're going to add some code to call those state transitions for our animation. And we're going to start by getting a variable that will hold that reference to the animation state machine. And in our ready, we're going to need to get that reference. So state machine equals animation tree get, and there's a parameter that we have to get. Parameters playback is the parameter one. Now we have a reference to that, and that's going to get us this root node, this animation node state machine node, which has all of the functions for calling the individual animations and making those transitions. So for example, let's start with the simpler ones. Let's say we want to be able to play the hurt animation when the player gets hurt. So whatever item is damaging the player could call the player's hurt function, which is going to tell the state machine to travel to the hurt animation. And what travel does is find the shortest path between current node and the one you're going to. So if we're in idle and we said travel to attack 2, it has to go through attack 1. That's how travel works. And then we could have the same thing with die. When the player's health runs out, we could tell it to travel to die, and we could also set physics process to false so that we can't even move anymore. Now we want to handle some of the movement animations. So in our get input, we're going to check get the current animation state, which comes from state machine.get current node. And that'll tell us what node is currently running, like idle or run. And then once we check our inputs and get our velocity, we can put here if velocity.length equals 0, then we want to be in the idle state, so we're going to say travel to idle. And then if our velocity length is greater than 0, then we're going to travel to the run animation. We can also check for our attack input here. So after we set the speed to 0, we can check if his action just pressed, and we'll check for the attack action. And if we did, then we're going to travel to attack 1. And I'll copy this here. And then I also have an input called big attack that lets us call the attack. We're going to call attack 2 number 2. I haven't changed the names here, so I'm just using the defaults. So we want big attack child attack 2, 2. Now, if we go to attack 1, like say we're in this state, so we're going to here, but we call idle or run, we're going to jump back. So I'm also going to return if I'm attacking, so I don't check the other inputs and set this and try and set the state yet. So let's try that out. So here I am running around. I'm in run when I'm moving, I'm in idle when I'm not. If I press attack, attack happens. If I press big attack, I get the double attack. And if I attack while I'm moving, I can still do that. This tutorial
In this video, you will learn how to create a simple state machine that will give you better control over your code, making it easier to implement AI into your games and allow you to automate certain behaviors. Howdy, and welcome to Game Endeavor. State machines are a vital part of coding complex behaviors in your games, such as wall jumping, climbing ladders, and enemy AI. It allows us to organize our code and limit its scope based on its current status. I use them daily in my developer job, and in this tutorial, I'll be showing you how I quickly implement a reliable state machine. Let's go ahead and get started. We're going to be creating an abstract state machine, meaning you will never use the script directly. Instead, you will always inherit from it and call the method hooks that will provide. The state machine will be a script that will attach to any node, meaning we don't need a dedicated scene for it, just a script. We need to keep track of the state that we're currently in, so I'll create a variable named state. Sometimes it's useful to know what the previous state was as well, so we'll create another variable named previous state. The state machine is going to act as a sort of interface. It's not going to perform any actions on its own. Instead, it's going to check some conditions and then tell its parent what it should be doing. To do this, we're going to need a reference to what we'll be controlling. So I'll create an onReady variable named parent, which will set to the return value of getParent. Every tick, the state machine is going to have two phases. For the first phase, it's going to call the logic required for the state. For example, in a jump state, we would allow the player to move left and right. We would apply gravity, and then we would want move and slide to be called. But if we were in a wall jumping state, then we would not want the player to move horizontally, else they would fall off of the wall. So we're going to create a method that will handle the logic, which we'll name state logic. We're going to be calling this method in physics process, so we'll want access to delta. Go ahead and add that as a parameter. This is going to be a virtual method, meaning it's expected that we're going to override this method in the script that inherits from this. So we're not going to create any code for it here. We'll simply close this method with a pass statement. Next, we want to handle the transitions that change our state. This is where we'll determine if we can go from standing to jump transition. We're expecting us to enter a new, which will be the method if we exit some sort of state, which then we'll as for this new state. And that's the mechanism. In mind though, that in this state is not equal to delta parameter. We'll immediately the transition then you will be empty dictionary, equal to the size of the state dictionary. So the first entry will start at 0, the second entry will be 1, and so on. Now all you have to do is create a state machine that will inherit the script. Copy over the abstract functions to your new your script. Add your states in the ready method, and then you can initialize your state. You will most likely want to set your first state using the call deferred method. This will set the state during the idle time, which will allow the parent to populate the properties and be ready for manipulation. Because the state machine is the child of the parent, it will load before the parent. To help demonstrate how you would use the state machine in your projects, I have created a simple enemy AI that will stop moving when you're looking at it, but when you turn away from it, then it will chase you. And once it is within attacking range, it will jump at you as an attack. However, it will not attack you if you are looking at it. It will also turn to face you, but only if it is not attacking. Without a state machine, your code will be full of complicated if statements for each of these conditions. And this is a simple AI with only 3 states, but with a state machine, it is far more streamlined, easy to read, and a lot less prone to bugs. I won't go over all of the code right now because we will cover enemy AI in a future video, but as you can see, we have our state logic method. In this video, you will learn how to convert a standard player controller so that it uses a state machine. This is the first step to implementing advanced features for your players such as wall jumping and backflipping, and other effects such as dazed or death. Howdy, and welcome to Game Endeavor. Once you're ready to start adding advanced features to your player controller, you will want to prepare your existing player controller for using a state machine. It is best to do this early while your controller is still simple, otherwise it can be a hassle untangling your code. Recently, I made a short video on how to implement a simple state machine in Godot. We'll be using that during this tutorial. There's a link in the description and an icard in the corner if you'd like to catch up. Let's go ahead and get started. The state machine is going to call all of the logic for our player. The player script isn't going to process any code on its own, other than potentially the ready method. However, inside of our physics process method for the player, we currently have logic that allows us to move horizontally, apply gravity, and apply movement. We want the state machine to handle all of this rather than the player, so we're going to break everything down into small chunks that can be called independently. The code will remain the same for the most part, we're just going to section off what we already have. However, we're going to be setting our animations in the interstate method of our state machine, which means we won't need to assign animations in our player script anymore. So we can remove the call to assign animation and delete the code for the method as well. Now we want to section off the moving logic into a method called apply movement. With it, we're going to keep the code that relates to our movement, such as setting our snapping and whether or not we're grounded. Next, we'll section off where we apply gravity by putting it in a function named apply gravity. And finally, we already have our move input inside of a function. However, I'm going to rename mine since it's a little confusing. It will henceforth be known as handle move input, and I'm sure that changing this won't confuse anyone in the future. Now that we have our physics process removed, we can switch over to our state machine and start hooking everything back up. I've already prepared a player state machine that inherits from the abstract state machine that we created previously. First, we need to add our states, so I'll create the ready method, and add a state for idle, which will be when the player is grounded and is not moving horizontally. A state for run, which is where the player is grounded but will have horizontal movement. A state for jump, where the player is not grounded and is moving upwards. And finally, a state for fall, where the player isn't grounded and is moving downwards. Then we'll need to set our initial method, which we'll do by making a deferred call to set state, and I'll set my initial state as idle. As for the state's logic, it's actually pretty simple since we don't have any advanced. logic for our player just yet. This will be exactly like our physics process method for our player controller, except we're going to define the method we sectioned off. So first we'll make a call to parent.handleMove input. Then we'll want to apply gravity, so we'll make a call to parent.apply gravity. And finally we want to move, so we'll call parent.apply movement, and that's it for now. Not only do we want to transfer our process logic, but we also want to handle the input logic for our player inside of the state machine. This is because there will be times where you will want to handle input differently, if at all, based on the current state of the player. For example, jumping while idling is different than jumping while wall sliding. So we're going to cut the entire input method for our player script and plop it down at the beginning of our player state machine. We're going to need to make a few adjustments to it. Specifically, we're going to need to preface every method and variable previously belonging to our player with the parent variable. There are a couple more things we can do to better integrate this into our state machine. For example, with these 4 states, we're technically only grounded if we're in the idle or run state. This isn't important now, but in the future you may have a need to put even more restrictions on when you can call the jump logic. For example, if the player is either stunned or dead. So we can remove the check is on floor and instead check to see if our current state is either idle or running. One thing you will quickly notice with state machines is that you may need to make several checks for a state. It can be tiresome to keep typing out state equals. An alternative method to this is to create an array of the values we would like to check. Then check to see if the array contains the values that you want. This helpful tip comes to us courtesy of Kane. We would use this check to see if our current state is either idle or run. There's another one we can do here, which is for the variable jump logic. We only ever want to perform this during the jumping state because there's no point for us doing otherwise. However, perhaps in the future you would like to implement knockback or fans that push your player upwards. With this as it is, it would be able to cancel their upward movement by pressing the release jump. We can fix this by checking for the jump state, and then adding states for the previously mentioned circumstances. With all of that done, we now want to handle our transitions, which we'll do with a match statement checking the state property. We'll start with our idle state. The order that we check the conditions is important, so you want to make sure that we check for the critical state first. Jumping and falling are more important, so we'll check these first. We only want to check for jumping and falling if we're not grounded.
Oke, selamat datang kembali di tutorial Godot Indonesia bersama dengan saya Sulaiman Santoso, dan di video kali ini teman-teman kita mau melanjutkan pembahasan kita membahas tentang Landry. Jadi kalau di video sebelumnya kita telah membahas bagaimana menggunakan state machine yang di animasi yang menggunakan state machine sama video itu tentang Landry. Nah, ternyata bahwa si animasi itu juga bisa kita pakai, si state machine juga bisa pakai untuk animasi yang menggunakan Godot. Kalau ini kan saya punya animasi menggunakan Godot seperti ini, saya juga bisa melakukan animasi menggunakan state machine seperti ini. Jadi menggunakan animasi saya bisa pakai menggunakan si state machine seperti yang kita pelajari sebelumnya. Jadi kita tidak terbatas bahwa animasi ini hanya supaya dia bahkan lebih baik kalau animasi ini menggunakan yang menggunakan bone seperti ini. Nah, tapi di sini kita nggak mau bahas tentang cara menggunakan state machine, karena cara menggunakannya sama persis seperti kita menggunakan spaghetti. Nah, tapi kita akan menggunakan sebuah blend tree, jadi kita akan bikin sebuah animation blend tree. Nah, untuk itu saya akan pertama kali mengganti si tree room-nya ini menggunakan blend tree supaya kita bisa langsung lihat seperti apa sih animasi blend tree ini. Sebenarnya blend tree ini teman-teman kita bisa pasang juga di dalam si state machine ini untuk pasang blend tree itu kita sendiri. Lalu ini saya pengen bikin langsung supaya kita ada pusing dengan state machine ini. Nanti kita akan bikin cara pasangnya nanti di dalam Jadi akan clear dulu, clear, kemudian akan baru kita new animation. Dan dia akan bilang animation ini aktif, gitu. Oke, selamat datang kembali di tutorial Indonesia bersama dengan saya Sulaiman Santoso dan di video State Machine gak bisa. Jadi di sini kita akan membahas tentang cara menggunakan State Machine dan cara menggunakannya secara basis seperti kita menggunakan Spike. Dan kita akan menggunakan sebuah blend tree, kita akan bikin sebuah animation blend tree. Nah, untuk itu saya akan pertama kali mengganti si tree ini, nanti kita bisa langsung melihat seperti apa sih animasi menggunakan blend tree ini. Sebenarnya blend tree ini teman-teman kita bisa pasang juga di dalam si State Machine ini. Kita pasang blend tree, kita bisa sebenarnya nulis bisa langsung kita dalam si jadi kita akan clear dulu, clear, kemudian akan baru nantinya adalah untuk membuat sebuah animasi yang menggabungkan beberapa animasi. Kalau kita punya Spike Animation, kita tidak perlu menggunakan blend karena Spike Animation tidak bisa di-blend animasi karena kita punya gambar yang berbeda untuk setiap animasi dan kita bisa bikin. Tapi kalau kita menggunakan animasi yang menggunakan seperti ini, kita menggunakan satu dari itu yang kita buat kita sendiri. Seperti yang kita buat itu sebuah animasi, sebuah transformasi dua dimensi. Jadi transformasi dua dimensi itu transformasi alam itu bisa digabungkan. Jadi animasi yang menggunakan buat itu bisa kita gabungkan. Kita lihat seperti apa. Nah, ini adalah output teman-teman, ini adalah outputnya adalah yang menggunakan apapun yang sini. Jadi kita bisa tanya di sini ada tulis. Oke, kita bahas beberapa aja teman-teman semua tapi cara yang teman-teman bisa bahas dulu kurang lebih bisa besar di bantu saya. Oke, sekarang kita namanya animation karena kita buat teman-teman. Sekarang saya juga pengen lihat tadi yang saya tarik garis ini ke kalau saya tarik kalau kita pengen berdua animasi dari waktu kita ini kita nggak bisa melakukan segala sesuatu yang tidak ada nah itu menggabungkan teman-teman kita punya kalau add itu menambah animasi 1 dengan animasi 2 jadi butuh 2 animasi. Kalau add 3 berarti menambah animasi 1 dengan 2 dengan 3. Kalau blend 2 kita namanya menggabungkan antara 2 animasi. Kalau blend 3 berarti menggabungkan antara 3 animasi gitu ya teman-teman. Di sini ada add dan blend itu mirip teman-teman. Jadi kalau saya pasang sini blend 2 bedanya adalah kalau blend itu nanti ada transisi sedangkan kalau add itu nambahin animasi gitu ya. Jadi kalau di sini karena animasinya bentuknya sama mirip jadi kita nggak bisa melihat bedanya terlalu besar. Kalau itu saya akan bikin ulang sama blend 2 di sini ada 2 input ya kalau teman-teman lihat dan ini ada 2 input sama blend itu saya pasang sini kita pasang si ujungnya kalau bisa lihat sekarang jalan dua kalau saya kita kan sudah animasi sebenarnya itu bisa dimasuki yang lagi dari awal jadi kalau kita pasang jadi kita lihat sih itu berbeda kalau teman-teman pengen menggunakan animasi kita kali terus jadi disebut app juga mirip teman-teman cuman app itu nambah ini karena di sini animasinya dua-duanya menggunakan gerakan bone yang berbeda jadi kalau pakai dua dan dua sama ya tadi kalau blend menggabungkan dua transisinya sama ini kok lebih nambahin nah ini teman-teman kalau misalkan kita selalu bisa menambah kita nggak akan bisa dua seperti ini kalau kita misalkan menulis sebuah animasi yang jangan sama sekali aja teman-teman misalkan kalau di jalan kalau teman-teman misalkan dia pengen lihat kalau saya on misalnya dia bisa lihat saya masih di atas ini loh ini yang satu aja satu kali jalan ini bisa pakai buat teman-teman ya kita ini untuk animasi cerita kita tapi kan kalau kita mau set dia di dalam kita jadi kita bisa lihat kita fotonya apa jadi kalau teman-teman itu tinggal keluar seperti dua set parameter semacam itu teman-teman ulang salah satu selain dari ulang selain F2, F3, blend 2, blend 3 kita bisa kali kita bisa mengakhir kesempatan dan saat ini kita akan banyak dari sisi animasi yang akan jadi dua jadi dua gitu saya kita terus waktu dari jadi kita punya blend 3 dari sisi ini dari sini kita bahas dulu kita punya blend 3 lagi kalau bisa ada blend 2 blend 3 untuk perspektif blend 3 ini ada kasih apa gitu kan. Jadi di sini saya kasih animasi, animation. Kalau saya jalan ini